Hello, in this video, I will explain how to find V0 and the power delivered by the sources using mesh analysis or mesh current method. So our goal here is to find V0. Find V0 and then the power delivered by this 40-volt voltage source. So P 40 volt here. And then the last one, the power delivered by this 20-volt voltage source. So we'll have 20 volt. Good. And then what can we do from here? We need to use mesh current method. So we'll have mesh current method. Okay, what we need to do is we need to label all the loops. So we need to label all the loops or the mesh. Okay, in this circuit here, let's say that we have 3 loops here. So we will have this loop here, which is clockwise. I usually do clockwise because I'm right-handed. So it's easier to draw clockwise, right? So we will have IA. And then here, I also have this clockwise loop current, which is IB. And similarly, we have one more here. So we will have this current here, which is IC. So I name IA, IB, and IC. And actually, we can get the value of IA, IB, and IC using KVL, which is the Kirchhoff voltage law. So we need to do KVL for all the loops. Okay, let's exactly do that. First, we need to do KVL at loop IA. KVL at loop IA. What can we do from here? KVL said that the sum of the voltage in a loop will equal to 0. However, we have to be very careful about the sign here. Okay, let's see IA here, and the current is flowing from the negative terminal to the positive terminal in this 40-volt voltage source. So because it is entering from the negative terminal, so this one will be negative, right? So I will have negative sign. So I have minus, and the magnitude will be 40. Good. And then what's next? Let's move on to this 2 ohm resistor. So I will need to add 2 with it. But this 2 is a resistor. We need voltage. To get voltage from resistance, we need to multiply it by the current. And the only current that passes through it is IA. So I will have IA here. Good. Now let's move on to this 8 ohm resistor here. So I will have 8 there. But then here there are 2 currents that flowing through this 8 ohm resistor. IA is flowing down and then IB is flowing up. So I will have to write it. IA came first because currently we are working on IA. So IA came first. But then IB flowing to the opposite direction, I will have IB here. Okay, and then all of that will equal to 0. Good. Now we can simplify this. 2 plus 8 will be 10. So I will have 10 IA. And then minus, I will have 8 IB, right? So I will have 8 IB. And that will equal to, move this minus 40 to the right hand side. So I'll have 40. So we have our first equation here, which is 10 IA minus 8 IB. And that will equal to 40. Good, this is our first equation. And then let's move on to the second loop here. We can just play the same game here. So let's do that. KVL at loop I2. I mean loop IB. And KVL said that the sum of the voltage in a loop will equal to 0. Let's start from this 8 ohm resistor. So I will have 8 here. But here IB is flowing up, but then IA is flowing down. They are opposite of each other. But currently we are working on IB, so IB came first, but I need to subtract IA from it. So I'll have minus IA. Good. Then let's move on to this 6 ohm. So I'll have 6. And the only current that pass through this 6 ohm resistor is IB. Good. And then we will have this 6 ohm resistor. And similar to this one, currently we are working on IB, so we work on IB here. But here IC flowing to the opposite direction of IB. IB going down, IC going up. So I subtract IC from it. And all of that will equal to 0. Okay, IA only came from this term here, so I will have minus 8 IA. And then for IB, I will have 8 plus 6, that will be 16. Oh, no, 8 plus 6 is 14. 14 plus 6, that will be 20. So I'll have 20 here. And this is IB. And then 6 multiplied by minus IC, I will have minus 6 IC. All of that will equal to 0. So here we will have our second equation here. So we have our second equation here is minus 8 IA and then plus 20 IB minus 6 IC, and all of that will equal to 0. This is our second equation. But then we need to do one more loop here. Maybe let's clean this up first because we already saved the equation, right? So we can just clean this up. Now let's do another KCL here, but this time at loop IC. So we need to do KVL at loop IC. Okay, and then KVL said that the sum of the voltage in a loop will equal to 0. Let's start from this 6 ohm resistor here. So I will have 6 here, and that will be multiplied by IC because we are currently working on IC. So I'll have IC here. And then here we will have IB is going to the opposite direction of IC. IC going up, IB is going down. So I'll have minus IB here. Okay, and then let's move on to that 4 ohm resistor. And the only current that pass through it is IC. So I'll have 4 IC. And here the current flowing from the positive terminal. So we will have positive sign here. And the voltage here is 20. We don't need to do anything because we already have the voltage. So we have 20 there. So we will have 20 here, and all of that will equal to 0. Give it simplification here. This will be minus 6 IB, which is only came from this term, AB. And then IC will be 6 plus 4. We will have 10 IC. And that will equal to, let's move this 20 to the right hand side. So we have minus 20. So this is our third equation. Okay, we will have our third equation, which is minus 6 IB and then plus 10 IC. Okay, all of that will equal to minus 20. And what can we do for now? We need to solve the equation. So number 3 here, solve the equation. Okay, and maybe let's clean this up to solve this equation. Okay, let's do exactly that. So this is a linear system of equation. We have 3 variables and then 3 equations. So we can rewrite this in a matrix form like this. So we will have 10 and then minus 8 and then 0 here, right? From the first equation. And this will be IA, IB, and IC. IA, IB, and IC. Good. And then the second row will be minus 8 and then 20 and then minus 6. Good. And then this one will be 0 because we don't have the term IA. And then minus 6 and then 10 IC. And then for the result vector here, we will have 40, 0, and minus 20. 40, 0, and then minus 20. And then how to solve this? Yeah, if you solve this manually, it will take very much your time. So we will need to use calculator. So I usually use Casio calculator because it is cheap and it is functional and it can be bring into the exam. So I will have Casio calculator here, and we need to use equation solver, which is this one here. And equation solver is number 5. Good. And we need 3 variables, which is number 2. Good. And then we just plug in each row here. So we'll have 10, and then minus 8, and then 0. And the result will be 40. Good. And then this one will be minus 8, and then 20, and then minus 6, and then 0. Good. And now we will have 0, and then minus 6, and then 10, and then minus 20. The x value will be our IA, right? So we will have IA, that will be 5.6. Our IA is 5.6. And the unit, I think that will be ampere because this is volt and this is volt. So we have IA. And then what is IB? IB is the Y value in the calculator, right? So we will have 2 ampere there. And IC is the Z value in the calculator. So we will have minus 0.8. So I'll have minus 0.8 ampere. So maybe let's label all the loop here with the respective value here. So I will have this one will be 5.6 ampere. And then here we will have 2 ampere. And here we will have minus 0.8 ampere. However, that means that actually the current goes there, right? Because we have the minus sign. So we will have this current here will be 0.8 ampere. Good. But then this is not our final goal. Our final goal is to find V0 and then the power delivered by this 40 volt voltage source and also the power delivered by 20 volt voltage source. So we need to plug in the values into this formula here. So we will have to clean up this first. So the very last step here will be answer the question. Answer the question. And what is the question asking us? First, it's asking about V0. Okay, V0, where is V0? V0 is the voltage across this 8 kilo ohm resistor. But the positive one is here, so the positive current will be this IA, right? It's flowing from the positive to negative. So we'll have IA came first, and then IB comes to the opposite direction. So I subtract IB from it. And then, because voltage is current multiplied by the resistance, we multiply it by 8. Then plug that in, so we will have V0 is equal to, I think we will have 5.6 minus 2 multiplied by 8. And so we will have V0 is equal to 3.6 multiplied by 2. Therefore, V0 is 7.2 watt. Okay, that is V0. And then the next thing that we need to find out is the power delivered by 40 volt voltage source. So we'll have P 40 volt. Remember the formula here, because it is delivering current, right? The current goes into the circuit. So we will have minus, and then the voltage multiplied by the current, but the current that passed through it is IA. So we will have minus what? Minus 40 multiplied by 5.6. And I think I just use calculator for that. So 40 multiplied by 5.6, that will be 224. And the unit will be in watt, right? So we have watt, and do not forget the sign, the minus sign. It is delivering the power. So we'll have that one. So we have P44. Okay, that is the result that we wanted. And then what else? We have to find out the power delivered by that 20-volt voltage source. So we have P24. And again, we will have minus the voltage multiplied by, not IC here. IC is going here. The current that goes into the current is this one here. So I will have to multiply it by 0.8. But then the value of V is minus 20. So I have minus 20 multiplied by 0.8. So that will be, I think that will be minus 16. Yeah, minus 16. So this is the final answer of the question that we have it. Okay, and I think that's all for this problem. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.